All right, so welcome back. This is week 7. And this week, we're going to revisit this concept of a UV map, basically texturizing, materializing your model. I think by now, you've been going through in the last course in this aspect. I found that some of you grasped that quite firmly, quite well. And whereas others are still a little bit struggling, understanding the process and then didn't grasp that so roughly. So I feel it's necessary for you to revisit that and discuss that in a more in-depth sense of that, to try to understand the process so that it helps you to build your materializing, texturizing skills. I think for you, so technically there's no new stuff, but you need to have a bit of a more insightful understanding of that. So in this video, I introduced, I'm not going to play here, but I suggest you to watch it. It's like 20 minutes, half an hour, sort of from a YouTuber, which I subscribe, which is, he is very good at that. He's discussing this aspect, especially the mapping and also UV layout, quite in depth, quite insightful. And I summarized that a little bit for you, because he's according to him, you have to form a habit of checklist before you delved into this aspect. And you firstly need to organize your UV layout according to optimize that to whatever you want to be, human-centric or computer-centric. So for example, in this screenshot, you will see that. What do you think? Is it human-centric or computer-centric? Anybody? No? Character-centric. You can say that. Yeah, that's good. Yeah, it's human-centric. Yeah, because you're beginners, you want to, because the model is organic, it's complex, and you have to going through cut individual patches and organize that. It could be very abstract. So that's why you need to organize your layout in this way so that you understand what you're mapping, what you are organizing. So as you can see, it's symmetrical, it's centered along the center, and it's from top, from the skull to the toe, and organized in a very logical way. That way, as a beginner, most of you are beginners. So as a beginner, you understand which one belongs to which one. So that's human-centric. However, what do you call it? The computer-centric, that means, as you can see, if you do this way, you have a lot of marginal area that's not being used. It's actually computational wise, it's kind of an inefficient and kind of not economic. Professionals try to utilize the whole texture space as much as it can, just to try. If it's doing this way, it will be considered unprofessional. But however, for us as a learner, this might be a good approach for that. All right. So first, you need to decide which way to go. All right. And then you want to deliberately try to avoid overlapping. That means patches don't overlap each other. Sometimes you deliberately, if you want to have the patch, a separate patch, share the same texture, you deliberately put them overlapped exactly so that they share the same texture. And but usually that's the principle. You don't overlap them. All right. And nothing goes outside UV tile. This is the tile. This is the texture space. Nothing goes outside that. That's the principle. Usually we just using this space for all the textures we use. The maximum resolution for that single texture allowed for a single texture space allowed is over, as I remember, is over 32 or 36,000 pixel. You can do as much as that resolution. All right. Later we will discuss that a little bit deeper, but usually you don't want to go outside that. Never place your UV island on a very edge of the UV tile. So these are called UV island patches, in Maya term called shell, UV shell. Try not to get too close to the edge and not to overlap each other as well. So that's the principles, and keep the same space between the UV island. So that actually, this human-centric, you don't really need to worry about that because it's plenty room in betweens. But if you're using computer-centric method, sometimes you're running out of the space and you put them too close together, the color of that pixel might be bleeding to the neighbor pixel as well. So try not to put them too close. The spacing should be consistent. All right, and keep everything same UV scale. They coined this called the texel density. So it's a texture pixel density. Which means, so as you can see that they have, in this example, it's the checkbox, but the checkbox size is consistent. See, the size is consistent across the surfaces. That means these size of these patches, this UV island or shell, are consistent in terms of size. The size is rather, they have all has different varied shape, but you still need to maintain a roughly consistent sizing, and you can check that by the check pattern available in Maya to see to maintain that. All right. And so the orientation of the UV island should be the same. This is still the same case. So it's top down. So everything is top down, top down. Try not to, if, for example, this arm and patches, if it's rotating horizontal way, it looks weird. It might still work when you produce the texture, but yeah, try to make them consistent in terms of orientation as well. And make sure UV layout is logic. So in this one, it's totally logic, right? Top down, left and right, symmetrical, all that. But if it's otherwise, it might you need to organize the UV layout understandable to yourself. So you make them so you make this one understandable to yourself. So later on, when you come back to modify that, you always know which one belongs to which. All right. So that's keep and make it symmetrical if possible. Yeah. So in this case, totally symmetrical. All right. But it's been hard sometimes, hard to maintain that. So just as much as possible if you can, and always test your map before starting texturing. So like in here, you always in my viewport, you turn on the shader mode, shaded mode, texture mode to see the texture preliminarily and see the effects. Sometimes you need to even hardware rendering a little bit or test rendering a little bit to test that. All right, before you actually satisfy. The last term called the UDIMs is a fancy term for a specific way of texturizing. Later we will discuss that. I put it here, just the video put it here just for your information. You are not likely to going to use that. It's used in the game industry for big project, for big texture tasks. Later we will discuss that in this slide later on. Okay, so as you can see, this is obviously this one is the computer centric, right? And so everything try to optimize utilizing the whole texture space as much as it can, as efficient as it can. In this one particularly, each patch is actually overlapped because I made it left and right. I made the half of the texture patches and duplicate the other half. Do the UV layout and duplicate the other half. So they share the identical patches and overlaps. So you only just need to try to reduce some of the workloads. You just reduce the half of the face, half of the vest, half of the arm. Everything else is falling into the place, but only with this unique item, such as the stain at the front, or you have a special one for that. All right. This is the computer centric. This one. All right. So this is another example of computer centric. Some of the modelers try to stretch each patches into more or less a square, so that it totally utilize the more efficiently utilize the space, and then they map out everything else. So once you have a very neat layout, and then you map out everything else, and eventually it comes into this. This is an example. You can see that. All right. So that's computer centric, but it still follows those principles. Have to use them still very logically. Orientation is maintained, and the distance between the islands are maintained, and try to not get outside the texture space. All right. So that's that. So UDIMs, that's another techniques. It is essentially, as I said before, usually we just using the first tile of the UV space, the UV layout space. But there are more, as you can see in the interface, you see that there are more tiles actually. You can use them. Sometimes you outside that, it's still technically allowed, but as I said, the limits of a single tile can go as high as into more than 30, almost approaching 40,000 pixel. But that means you have a single texture. If you prepare a single texture that big, it's computationally heavy. It might not practical for big game engine to run. So hence they invented this method. They, instead of having a single large texture, and then for everything in the scene, they actually cut them into smaller pieces. So, and then arrange them accordingly. So that's so the way they arrange them, they separate the texture space into columns and rows, and then label them, number them this way. So from the first one all the way down to the 10th one, and go up, go up. That way, so you follow this order. So from left to right, from bottom to on top, so that you have a internal order of this tile. And then use the computer, and then you distribute all your textures on these tiles. And they're gonna use computer internally to actually make the connection, which part of the scenes patches, polygon faces going to utilize which tiles texture. That's the whole idea. And the reason why is that you can obviously see that. So for example, if you have a creature, you want to map its face, right? If you're using a single tile, everything have to squeeze into this single tile. And so the texture occupies the face part, only occupies this much in the texture. So what if in the game you have a player approaching to this dragon very closely? So what's the texture going to be? It's going to be pump up and going to be blurry. It's depending on the resolution of that single texture. So it's going to be an issue. You want to solve that. So of course, you can do a maximum resolution texture, this one, but as I said, it's going to be computationally too heavy for the game engine or any other engine to play with. So the solution is using this, using multiple tiles, multiple texture space tiles. So in this case, you can see the face part is occupied the second. So second tile. So this way, that single tile can have like a 4K. So instead, you have a maybe 16K picture, single picture, you can have multiple 4K picture organized this way, so that each one, so the computer, the render engine know which part you're gonna connect to which tile to actually apply the texture to. So this way you are guaranteed, they call it a texel space. You guarantee the consistency of the quality of the texture. So that's the whole idea. However, I don't think you get a chance to use that, but for your information, in case later on you land your career path to this way to the game company or that, at least you know there's a solution for that. All right. So that's the whole idea of so they call it the UDIM. I think it's UV dimensional, something like that. I forgot that I forgot the terminologies, acronyms stands for. Let me just maybe double check that. What's the UDIM by definition means? Okay, UDIM is it's a system of a UV mapping that allows multiple UV tiles. Each contains a unique texture. This setup is very useful to creating high detailed texture by utilizing multiple smaller image files to form a single cohesive sequence. It still doesn't say what's the UDIM acronym stands for. All right, doesn't really matter, just for your information. That's one of the industrial standard approach in solve the issue of texture consistency and quality, maintain quality. All right, so another video from this same YouTubers also surveys through all the texture map method available to you. So far, you've already been experienced some of them, but some of them you might not encountered yet. It depending on the scope of your work and the depth of your work, 3D work. You might never encounter some of them, you might encounter some of it, but it's basically, it's just categorized into two categories. Among all the maps, and there are two categories. One is the shader maps, that including this many, and mesh maps or mask maps. This include this many. All right. So as you can see, you already done a lot of them. So a albedo map, usually called color map, right? Roughness map, usually sometimes it's also called glossiness map. All right, displacement map, a bump map, normal map, opacity, metallic, and even a fancy one called vector displacement. All right, and others are dedicated, it's basically black and white. All right, so those maps are usually just black and white. So those maps are basically a mask map. They actually for their specific functions. So let's just go through that. So a albedo map, which means you just having color information for that texture part. So usually I see students work, their color map, they just take a picture of maybe for example, a brick wall. They take a picture and apply it to the color channel or color properties of a material node. But that's actually not a proper way of doing that. It's considered that if you have a picture of, for example, a brick wall, not only it contains the color information, but also it contains a lot of others like the shadow information, the lighting shadow in situation, and then so you can actually derive from single picture in Photoshop. I show you in the last course. So you can actually derive from the single picture photo to have a normal map, and sometimes have a mask map so that you later want to do something with that. So it's black and white, and more importantly, you just want information of the hue of the color. All right, so from here to here, you can see that this albedo map only have color hue information, doesn't even have shadow information, and that the darkness is not representing the shadow, it representing the hue level of that. All right, if it's dark, it means the hue is the color is dark. All right, that's the albedo map function for just for color information, no shadow, no other information. All right, that's ideally what you should create if we want to bring some color texture to the albedo properties, like either in Maya color property or in Sketchfab's albedo property node. Roughness is defined by definition, it controls how rough or smooth a surface appear to be, and it affects the sharpness of reflection. And usually, you just determines the spread of the light on the surface. All right, that's why. So you have roughness as 0. You have sort of totally smooth reflective surface. And in the middle, you have matted one. And if it's totally, that means that the microscopic level of the surface really rough, and it doesn't really reflect the light in a particular direction. So that's the roughness map for. So sometimes I saw students work, you can see they confused. They don't know what's the roughness represents. So they apply some text, even colored texture to this property, and doesn't really do the job well. So you have to have a roughness. Usually it's also black and white. So the roughness, the black and white represents the microscopic levels of roughness. All right, so it controls the glossiness. Sometimes they call it glossy map as well. So in Sketchfab, you already should experience that. You can switch. It's actually share the same nodes. You can switch node. Whether it just means the black and white reversed. So if you do the glossiness one, that means the white. I think the white represents a smooth, but for the roughness one, the white represents the rough. So it's interchangeable. You can switch between the two methods. All right, but just be aware it's controlling the glossiness, the surface smoothness. All right, so bump map, normal map, and the displacement map, that's all about the surface relief. This is the difference is that the displacement map actually altered the surface polygon vertices. So it changes surface geometry, whereas the normal and the bump doesn't. All right, the bump is the initial one that you just simulates the surface relief, and not actually changing. The normal map is actually at the more advanced fancy level of the bump map. They're the same. The good thing about that is the normal map also change the surface relief. You can actually bake from high definition model to the low definition, transfer that. And it interacts with the light situation. If the light moves around, it will interact as if the surface has real reliefs. but it's not actually. It's still simulation rather than displacement map doing this. It's actually alter the surface points. And okay, so other texture map like ambient occlusion map. This is ambient occlusion is simulating the shadows in the crevices, corners where ambient light is naturally occluded. So hence the ambient occlusion map. And the cavity is similar to ambient occlusion, but focus on more on small crevices and finer details, such as this one, so like the wrinkles of the surface. And so sometimes you want to emphasize on that. That's for that. And the curvature map is usually for the wear and tears. So like the corner of a piece, there's more wear and tear over there. So the curvature map can generate a black and white map. You using Arnold in Maya, you using, I'm not so sure in Blender, it should be a similar one. You have this shader node, so it can generate it amount of the corner based on their curvature, and so the less curvature, the less the amount of the whiteness. So this way you single out those areas, so and then you apply some to the surface, and that means those areas are wear tear. If you have combined with the color map albedos and other maps, it will generate kind of a wear and tear, rusty sort of corners, and that's the curvature. And the thickness is like this. It's just measure the thickness of a surface and provide a different value based on that data. So it is useful to simulate subsurface scattering effects, especially for organic material like skin. So more obvious example is the air path, so like that, the light from the back. So how much a semi-transparent, that map defines that. So it's also black and white. So that I think it's more white, that means more thin. So the thickness map is basically for those material like jade or that. All right, so if you apply that, it's doing this. All right. So there's a confused term of specular or metalness map. So how do you differentiate them? In Sketchfab, you'll see that once you get into Sketchfab, you see you can have two buttons, whether you want to do metalness method approach or you want to do specular method approach. What's the difference? So this video talks about that. It's a bit short, so I just maybe place that. Just play that. Explain quite thoroughly about that. Although he uses Blender, actually.
Physically based shading has been a popular topic recently, and for good reason, because it helps simplify the process of making good-looking materials. But like with OpenGL versus DirectX normal maps, some companies disagree over how it should be done, and so different software packages end up with different ways of implementing the same general concept. Some programs use the metalness workflow for PBR, while others use a specular workflow, and still others appear to use a combination of the two. There are many different texture types out there for physically based rendering, and so it can get a bit confusing. In this video, I just want to go over the ones you're most likely to run into and how to use them, because some are only intended to be used in combination with others. The core of the metalness workflow is made up of three components: color, microsurface, and metalness. The specular workflow, however, is made up of color, microsurface, and specularity. So of course the big obvious difference here is between metalness and specular maps, as the names imply. Metalness maps are only black and white to show which parts of a surface are metal or non-metal. In the metalness workflow, the color of the metal comes from the base color. The benefit of this is that since it's only totally black or totally white, it can be compressed quite a bit with no noticeable loss in quality. Specular maps, on the other hand, do have colors in the areas that should be metal, So in a specular workflow, the color of the metal comes from the specular map and not the base color. Since the specular workflow uses color to denote which is metal, the brightness of the map controls the reflectivity. It generally does not make much difference though, but if you do need to be 100% correct, then specular is probably the way to go, since the metalness workflow doesn't have a direct way to control reflectivity, but in most cases the difference is fairly negligible. Both workflows do use base color textures, which are also called albedo maps. These color maps are different from the old school diffuse maps in that they should not contain any shading information like shadows or ambient occlusion. In the metalness workflow, since the color of the metallic reflection comes from the base color, you would just use a regular base color texture like you're probably used to seeing already. In the specular workflow, since the color of the metallic reflection comes from the specular map, those areas of the base color map will be completely black. So an easy way to tell which workflow someone is using is to look at the base color to see if it contains the color for the metallics or not. The next piece of the puzzle for both workflows is the microsurface maps, which approximate the microscopic details on the surface of an object, making it appear either shiny or rough. This will either be called a roughness map or a gloss map depending on the software that you're using. They're exact opposites of each other though, so if you have a gloss map and you need a roughness map, just invert the colors. It's easy to confuse the terms gloss and reflectivity because the higher gloss something is, the more reflective it appears. So instead of that, think of reflectivity as the amount of light being bounced back instead of being absorbed. Gloss or roughness do have to do with how fuzzy the reflections may be, but they don't actually affect how much gets reflected in the first place. Lastly, an ambient occlusion maps help make up for the lack of lighting details in the albedo map. Separating the ambient occlusion from the albedo map in a game engine helps the light to look a little bit more natural. Ambient light is occluded in those areas, but dynamic lights, like a character's flashlight, won't be blocked. This type of map is only really needed for real-time games because animation renderers like Cycles will calculate this type of occlusion automatically along with global illumination. So as I mentioned before, most programs with PBR shaders still work a little bit differently from each other, so it's important to know which maps to use when the terms get a little bit mixed. As an example, let's take a look at the new principled shader that will be included in Blender 2.79. It has an input for base color, metallic, and specular. So it has both metallic and specular. Which map should we use? Should we use either one? Can we use both? Well, remember that the easiest way to tell, regardless of the terms the software is using, is by checking which input the color for the metals goes into. So in this case, we can see that the base color is a color input, while the specular and metallic inputs are gray, indicating only grayscale values. So even though it has the term specular, the node is using the metalness workflow. And usually any program that has a metalness input will be using the metalness workflow. The specular value in this case is controlling the reflectivity, meaning we have the same amount of control as a specular workflow, but we're still using the more intuitive metalness paradigm. I hope that clears up any confusion between the metalness and specular workflows. Remember, don't get too hung up on specific terms because it can get confusing. But it doesn't really matter which software or jargon you're using, whether it's Cycles, RenderMan, V-Ray, Unity, Unreal, or even Marmoset Toolbag. Just look at which textures control the color of the metals, and the other textures you will need will begin to fall into place based on that. Thanks for watching, and I hope you found this video.
Alright, so as you can see, this explains all about these two methods. When you get into Sketchfab, you will see that in the material you can switch between whether you want to specular mode or metalness mode to do the job. All right, so the short let me just bring this one. So to summarize, conclude a little bit, simplify that is that I think for us, maybe metalness map is the way to go because it's more simplified way of applying. The workflow is try to define which surface is metal, which is non-metal, and everything else will fall into place physically because we're using physical-based render method. So it should be pretty much all right. But if you want to have control more specific reflection or highlights. Sometimes in dealing with surface like human skin, leather, or some of the complex surfaces, you have specific needs to tweak the reflection, the shininess. You might want to use the specular map. All right. So either way, but as in the video says, the differences is barely noticeable. It's actually it's so the easier way the better. I suggest. All right. So and on Sketchfab, we already show you on Sketchfab you have different. Sketchfab is using PBS, so physically based rendering surface. So it's all available. Those so you all you need to know now you know the function of different maps. You know which one to find, right? And to which one to apply it, right? Ambient map, gravity, and opacity. Even they have some more like emission, which means the surface can emit lights, so all that. All right, and even have a complex ones in Sketchfab. You have a clear code, which means you have layers of. You can even have even further layers of texture to apply to create very complex effects. All that. But it's for you to explore. If you can do all those previously mentioned map together well, it's already the outcome should already materialize pretty well enough for you to cope with any surface quality you are designed or desired. Right. All right. So far we were talking about all those maps and UV layouts, all that methodology, all that technology are the hacks. As I said before in the previous course as well, they are all hacks. But nowadays, with the launch of Unreal Engine by the by the what's the company called? I forgot. Unreal Engine 5. They actually use brute force, their algorithm brute force to actually kill them all, actually. And this one is already 5 years old. I think I have this YouTuber, which is a Chinese YouTuber, unfortunately, that he surveys through this evolution of shading and the CGs, shading the 3D models. I think it's quite good, and but it has subtext, so you can. I want you to go through some of them a little bit so that you understand the evolution of this shading aspects of CG. All right, and the Unreal Engine actually tackles all those problems and try to solve them once for all. Try to kill all this if it's to be true. You don't really the as a creator, you don't really need to worry too much about those technology. So far we are learning using multiple maps and the different mask maps or shading maps to simulate the surface quality. You can just or modeling the model in less using less polygon faces. This all can be solved if that engine is that much powerful. And I think this video surveys through this evolution quite roughly. Maybe we should play a little bit so that you see what we're talking about. So where is the this one?
三角形够小够多，我们就能看到复杂的曲面。所以根据
Unfortunately, it's a Chinese one, so I'm gonna explain through. Or you can. So it's starting from a very early stage of the. So where is it?
我的虚
Try
拟
to find.
曲线的只有是引入了第二种结我们也要每秒30帧。
So
那每
from the
秒30
early
这张图片，就算
from the
有人
early
说
stage
生
of
产出来的不流
gaming
畅，那也
technology
也没人
and
会这张图片啊，
at
还得
the
用
time
多绚丽
if
给
you
材质
want
啊、
to
灯光啊、特早期 T 恤
so
和劳拉的
early
手啊都是三角
at
锥，
the time
现在
that
不
was
是了，
like
有些的三角形得控制
early
在
2000s. If you want to have
当落到
3D
了
texture,
2010左右，
I
游戏里
the
就有
engine
很多
cannot handle them
签到放到
until
产品上去了。
the
而从2006年
this
开始的 Xbox 360
this is
游戏的场景
2005,
坦克
20 years ago.
已经非常
Now
之
the
快的拥有了，到了
play
PS4 和 Xbox One 系列，
PlayStation and
甚至是
Xbox
Xbox
can
4
deal
这个
with
场景都可以支持
200,000
1080的三角形。
uh,
很多呢确实
polygon
有时候里
faces
面表
now.
现一个角
So
色
things are
这个游
getting
戏真的，我
better,
们看死亡搁浅和这个看
more
似真实恶劣
realistic.
的克莱尔
Uh,
都已经很接近真人了。
as
现
you
在
can
踢法的
see
时
in
候，
this
就算把脸贴上去
this
啊，
in
也看
these
不出三角
games.
形的轮廓了。
All right,
这可能是别人看
and
但几百万个三角形
but
放在同一个
still,
场景，
even with
这个计算
millions
到
of
身体、颜
triangles,
色的
you
差
can't
异，
handle
还是不够
if you
的。
have a
大自
grand
然的
environment
制造
such as
是非常
this.
之复杂的，
It's
因此
still
即使
very
是现在
heavy,
用的是
tedious.
法线贴图，
Hence, they've
其实就算是
invented
20万个
more
变态角色， 依然做成
technology
依
techniques
然要用到
to
法
try
线贴
to
图和
use
特效
less
的设计能力
polygon
啊。
but
用 ZBrush 创
more
作的高
complex
模，在这通过一个
surface
复杂的
qualities.
步骤，
Hence,
让
we
它
have
虽
normal
然
map,
有高大
right?
的轮廓， 但
So
没有细节
you
的
can
细节。这个
transfer
步骤啊，做多了才知
high
道有多枯燥，且又
density
繁琐。
models,
初期建模
surface
有无中
textures,
生有的建模方
and
法，让
try
这个高
to
模可以用
later
艺术
bake
创作的乐
them
趣。
onto the
技术很
simplified
快，不用2周，
uh,
可以把高模的细节做到
simplified
60烘焙，像烤面包一样，
coarse
再用到法线的
polygons.
贴图上。 那贴图是这样的，看起来非常基佬啊。
So these
那
are
模型
the
的基
normal
佬技
map.
术原理啊，这就不说了。
It's around
它的
the
效果，整颗
2010
画面
something,
非常精细
and
啊，
this
大概有800个
technology
模型，可以
emerged,
看到脖子上每个图
and
片闪闪
now
的灵
you
光， 算
can
是 PS4 时代的级别啊。如果每个贴图
create
都需
more
要计算模
detailed
型本身，
surface
那细节点非
reliefs
常多，
using just single map
那贴上
to
法线
do
贴图
that.
之后呢，就变成基佬纸龙头了啊？不对，
All right.
这只是直接显示了法线贴图，并不是真正把法线应用到了模型
The
上。
model itself actually
这
doesn't
是没
have
有
that
法线贴
much
图的模型，
details,
而
but
这
the
是
map,
应用上法线之后的模型。
the
看到
normal
细
map
节少
added
了好几
the
个最后， 拉
richness
近看
of
看，原
that.
本是光滑而如裂空的，但贴上法线后，不仅出现了立体的瞳孔，连眼球的纹理都能看清楚。那身上鳞片就更不用说了，
And it's
并
interactive
且
with
这些
light.
是平面的，当转动了模型，光源产生变化后，就能看出这些细节都是立体的。再来对比一下，这是指贴上颜色贴图的，
So in comparison,
是颜色加
that's
法
with
线的
colors,
这就是
albedos,
法线
normal
贴图
maps,
能
everything,
大大
it
提高
looks
游戏的
much
实用性。
realistic.
当年第一批使用法
So
线
when
贴
it
图技术的游戏，
coming to
印象比较
beings,
各式
this
上百种适
every
合这些游
game
戏，
rushed
草本
in,
字里
game
能看
engine
到
rushed
细
in
如
to
指
use
甲的花
that
纹，能
for
如此
surface
跟
quality.
塔
And
塔的纹理，到现在看起
so
来很
there's a
不
period
错。
of time in the
因为在那
game
个时代，
industry,
因为
you
光滑性
have
很单一，
everything
想要
is
体
so
现出法线
looking
贴图
so
的效果，
greasy
使用高
because
光
they
滑的颜色
use
啊是最直
they
观的。
use
这
the
是有一些游戏为了证明
normal
这个
map
法线贴图，
intensively.
大幅加强了高光的
Alright.
颜色，导致这个即时游戏总有一种油腻腻的感觉哈，这很有意思啊。因为技术的变化，每个时代都有特定的审美和风格，
So
印证了上个
each
时代游戏
period
的
have
特
its
点啊。当然，
unique
法线
sort
贴
of
图依然有缺点，
followed
它
by
的
the
细节体
evolution of
只
the
是看起来立
technology,
体， 实
have
际
the
上仍然是
unique
立体
sort
的。
of
当它的大小变
aesthetics,
大，并且从侧面
industrial
拍照
standard
那就会露馅，
at
看
the
起来有
time.
很奇怪的感觉。其实对复杂场景来说，这种露馅啊无处不在。因此，业界引入了另一种贴图。
So then
这是
they
日本
they
技术的
they
样子，
found it's
用
kind
黑
of
白来代表模型表面的
not
色
so
彩。
satisfied,
因为法
and
线
they
贴图的设
invented
计，
the
它能真
displacement
正
map.
改变
All
模型
right.
的轮廓，即使没有计算机的模型，就
This
能
is
实现。
the
这是
displacement
有
map.
计算机之后的，从侧
Instead,
面
they
看
just
法线画得
extrude
真
the
实的看起来。
surfaces a
画的时
little
候也
bit
有
to a
节奏，
level
这些细节
so that
都有明显的
it
拉扯痕迹。
using the
其实
black and
完
white
全需
to
要模型
represents
本身带有
the
创
map
性，
represents
消
the
耗的成本
depth
很大。但
information.
如法线贴图般大
So
量使用，
and
因此到
change
现在游戏
alter
里
the
还是不
surface.
可能
As you can
到
see,
了
a
最后没
flat
对比。
surface
这是只有颜色贴图的一个
can be
纯技术点
extruded
啊。为
to
了
a
体
certain
现效果， 我
level
也学那个时
that
代的油
almost
腻感啊。 当只有
looks
颜
like
色
a
贴图的
real
时候，
thing
光线在上面
when
晃
and
动，模型
interactive
是没有
with
细节的。
the
现在加入了
light.
法线贴图，模型的细节 节增加了，光线划过时
and also all the details as well.
现在慢慢的提高置换的效果，哎，整个模型立马栩栩如生。从远一点来看，几乎可以乱真了，
almost like the real thing. But don't overdo it. If you overdo it, but it's still if you overdo it, it will, defeat its purpose. All right, it's
这个模型
gonna.
虽然没有高博那么夸张，但依然要占据不少的计算资源，所以置换贴图不能大规模使用。
So you can't use them
总而言之，就是人
quite
们为了在游戏里使用
ubiquitously.
更多的模型，想尽了各种办法。从最初的
Bump
高维
map,
贴图，到
normal
被
map,
到的
they
纺线贴图，
they
再到
usually
改变模型的自传贴图，再配合
combine
硬件性能
to
最优的
use.
三角形树，才做出了现在美轮美奂的游戏画面。越来越大，玩家依然能看到模型明显的边缘，特别是游戏的场景越来越大，视角
But
还能自由控制。同时，游戏引擎
there's another issue of called local details.
LOD 是
The
level of
details over
是控制
distance,
细节。LOD 可以根据
level of
距离来自
distance.
动减少
So
模型的细节，
in the
让远处的物体
game
减少变质。
engine, the
谁才算
distant
力给玩
objects
家自由
should
控制，
have
这个就是
less
让场景可以轻易变顺，
polygons.
提高
So
了
you
效
have
率。
different
设置
versions of
LOD 方
that.
面非常麻烦，并不是
I'm
具
not
体
so
的
sure whether
特
you
殊
experienced
重要。
that before
有些大
in
型
playing
虽然
games,
很
the
远，但是
distance
很
change.
显眼。
But this
如果
causes
超人按照计
new
算机自动选择
issues,
LOD， 就会出
like
现
the
被靠近一
change,
点，模
sudden
型会
change
变质
of
这样的
the
突兀情
elements
况。
in
如何设
the
置场景里的
game
每个物体
environment.
的 LOD
In the
是一
game
个
world,
非
as
常
you can
繁
see
琐、
here.
非常复杂的工作，又要兼顾到同屏三角形的数量，
So
又
the
要计算
challenge
模
will
型一
lies
点点
in
的变化会
how
突然变化，
much
还要
you
考虑玩家可
reduce
以在
this
任何地
sudden
方
change.
看向任何方向。 如果
You
是开
try
放世
to
界无缝地图， 光
try
是这
to
一个步
make
骤
the
就能
transition
让
more
游戏体验变
seamlessly,
个半
but
年。让我们
it's
再来
never
看这个
been
不爽点了，等一下
perfectly
实验我们
solved,
会出来。
this kind of issue in the game. Hence, we have now the Unreal Engine, and
好，讲了10多分钟技术原理，终于
they
可以看到 Unreal
claimed
的渲
they
染器
can
问
do
题了。
that.
如
All
果真的
right,
如
so
演
they
示时
solved
贴
the
图，那
problem.
Unreal 5
So
上
everything
面所有的
is
技术就都可以被干掉了。从今往后，做好基础模型，
so
丢到计划
everything
里
is
有可
real
靠
time
就可以
and
直接导
render
入游
real
戏里
time.
使用了。除
And
玩
no
家要
matter
持
how
续
many
画面将
polygon
模
you
型的
have
体验
or
力强化
texture
使用
or
者的能力，
distance
有
you
超火
have,
箭级别的
it
画面
can
体验的
do
提升了。
all
模型里的
that.
每个细节都将丝毫并线。另外，现在有人总觉得贴图不够清晰，就算是4K 贴图，靠近的看一样模糊。而再
So
提高贴图
it
时段
combined
细节
with the
度，
real
让
life
整体
scanning,
看起来更
3D
清晰。因为
scanning
过
of
去
the
很多要靠贴图来表
terrains
现的细节，
with
现在
every
可以直
much
接靠模型来体
details.
验了。还有树叶、
So it
草
can deal
地、
with
树木，现在可以
organic
使用一个面片将不明
objects
变
such as the
的所有的
trees,
杂片
unlike
然后
before the
放好
tree
来交
leaves
叉
are
放给玩家
actually
这样难
like
免
a
会有
piece
碎
of
片
paper
设计
and
角度
you
确实在哪
changed
里。
its
未来
direction.
每一片叶子
But later
该怎么
now
做
you
都将不同
can
的模型，
actually
玩家将会看到无比的
render
细
each
节
individual
可以
leaves
而整个场景更
and
是不用考虑面部
in
限制
respect
了，
to the
想做多
lighting
大就做
situation.
多
So
大，
like a
就如演示
statue
中的
like
细节
that,
超过了
easily
3300
over
万的
32
参
million
数。本来像
triangles.
个场景，
And
现
you
在玩家
have
放了5
more than 500
用
of
超
them.
过了
But the
160个
render
三角形，
engine can
当时
deal
大
with
家就
them
爆炸的怒气，
effortlessly.
天哪！
And in
对
real
整个开
time,
发者来说，那更是
uh,
如沐春
in
风。
real
开发
time,
者将省掉大
responsive
量工
to
作，
the
因为开模之
lighting
后，不再需
situation.
要无聊又花时间的
So
通
all
过，这么
the
久积累的怨念得以发泄，马屁撞
so-called
人， 然
normal
后
map,
不再需要
bump
后面
map,
花时间
all
置
that
换贴图。
displacement map,
这部分烘焙的
you,
过程需要大
you,
量
you
时间，
don't
虽然
create a
这些
can, you
图
usually
需要再
so
调整，
worry
发现
free.
和置
You
换是
don't
非常
need to
麻烦
worry
的。
about
它
them
不像其他
because
模
when
型，
you
一
edit
帧
the
不能
normal
解
map,
释就
you
能看不出来。
you still
发
need
现和
to
置换
manually
会改
fix
变
a
整
lot
个
of
视
the
能体验，
flaws
有
and
推进一点不自然的
it's
画
very
面，模式
easy
上
to
不会
see the
特别扎眼。
flaws
调
if
整
the
时，
map
在
is
3D
not
软件里
doing
和引擎里想还
well,
不一
not
样，
quite
需要来回对比
neatly.
再调整贴图，
All right,
同样会花
so
大量时
in
间。
order to
而
avoid all
后来
these
才是最过瘾
technical
了，更
issues,
甚至还
the
能直
Unreal
接导入
Engine
3D 扫
claim
描器
it
来
can
扫
do
出来的
that
模型，
in
这不
real
仅细
time
节更加真实自然，
once
连
for
建模
all.
的时间都省了。
Kills
让
all
3D
the
图的美术更
methods
扎
so
实，
far we
这些
are
延时生
talking
成的模
about
型都
learning.
来自于
So
推手平台，
it
没
claims
关
that
系， 没有
these
在美
videos
国
are
生产，
all real
可以实
time
现随时
and
当 3D 扫描
the
贴图的
geometry is
使用。
all
所有它的模型的各种
3D
贴图基本都是细节
and
极高的高模，给了钱就可以商业使用。我所知，很多影视动画都
a
是
lot of
的，
them
在游
is
戏业
just
用不了，
directly from
买
the
回来还要
3D
拓图烘
scans
焙，
from
省不了
nature.
多少时间，还不如自己做。但
So
以
that's
后
why you
游戏团队
see
也可以直接使用了，也不是很
the
贵。
Unreal
这意味着
Engine
只要
can
愿意
do you this lighting situation in real time with all the details maintained.
对了，用 Epic 的晒盘大旗呢，还没景都一样细节丰富。
And the issue of LOD, which is level of distance, also solved. The last bit of this Unreal Engine, just trying to demonstrate that. As you can see, the fly-through thing, everything is seamlessly all the way stretched to the distance. There's no sudden change at all. And everything is looks so real, realistic.
那多放一个，并不会增加贴图所占的内存和显存空间。那省下来的时间，要么可以降低开发成本和时间，要么可以花在构建更好看的场景上。总之，对玩家和制作组都是受益匪浅的。但刚才说的都是和表现力有关的，那和游戏玩法就完全没有关系了吗？其实也不一定，这个我们后面再说。先来看看。
All right, so that's I think. So that'll be it. That's all I want to talk about this week. And so you this week's tutorial, you need to the first thing is to how do you dissect the surface realistic and cut them into different pieces. I curated this two simple videos and teach you how to do that, cut the scene, and how do you cut the organic complex models into different patches, and also for the clothes as well, and organize them. Maybe initially you're from the human-centric method to actually helps you to understand each cuts, each patches. And of course, you can use advanced tools such as substance painters to achieve that in a single workflow. But the uni doesn't have that. But personally, you can download a personal version as a learner. You can download them and try them out. Some of you in the last course already do this quite well, but it's not necessarily required. And you can, if you can, you do that by yourself. Otherwise, you just need to concentrate on doing the layout neatly, well, and produce textures accordingly. And now you understand the function of different textures. Yeah, I have confidence on you, in you about creating, judged by your previous courses result. I think you can achieve quite a bit of a realism for your character. All right. But the first thing first is try to create the layout, the UV layout, neat and more precise. All right. Any questions? Oh, good. All right. Okay, so without further ado, just delve into the still working. Oh, okay, so no. Yeah, no worries.